Alright guys, today we're going over 85 through 87, so let's just get started with number 85. Alright, so for this question, we are going to be using the derivative to find the relative maximum value of this function. F prime of x is equal to e to the x minus 3x squared. So right off the bat, you should go to your calculator. And I already have the function inputted here, so you go to graph. And wait for it to load. And then you see that the derivative function here crosses the x-axis, which is going to be the zeros, 3 different times. But what you're going to have to look for is the points where it goes from positive to negative in the y region, because those are going to be your relative maximum points. And so I'm going to see that this point right here is going to be the relative max. So I go trace to 0, left bound up here, right bound down here. And then we get the x value for this is equal to 0.91, and with a bunch of zeros at the end. And then that is going to be equal to c for your answer. And then the trick for this one is realizing that only certain ones are going to be your relative maximum value, and the other ones are going to be your relative minimum values. All right, let's go to number 86. So for 86, we have f of x is equal to the square root of x. And then we're going to have to find a value, x is equal to c, at which the rate of change at c is twice the rate at x is equal to 1. And so what we're first going to want to do, as soon as you see rate, you're going to want to think it's a derivative. So f prime of x is going to be equal to 1 over 2 root x. And then from that, we're going to plug in 1. So 1 over 2 root 1, and that's just going to be 1/2. So that's going to be your f value at 1/2. And then from this, you're going to want to take double that value. So you're going to want to get 1 when you have 1 over 2 root c. And so you should automatically think 2 root c is equal to 1, and then this 2 should go to the other side, so root c is equal to 1/2, and you guys should obviously know c is equal to 1/4, because that's just the square root is equal to 1/2. And the trick for this one is automatically knowing that rate of change is linked to derivative. That's going to be the key to solving this problem. All right, and then the last one, number 87. Okay, so the domain, they're automatically stating in the beginning, t is greater than or equal to 0, and then they give an acceleration function, a of t is equal to t plus sine t. And then it says that t is equal to 0, velocity of the particle is -2. So when t equals 0, v equals -2. And I'm gonna want to save that for the future. And then what value of t will the velocity of the particle equal to 0? So right now we have an acceleration function, and what we're going to want to change is turn the acceleration into velocity. And we should know at this point that v of t equals the integral a of t. And the integral a of t is going to be equal to the integral of t plus sine t. And if we just do a little bit of algebra, we get that the integral of that function is going to be equal to x squared, and I'm just changing it to x here, it's the same value, over 2 minus cosine of x plus c. And we're going to want to have that c value here, because this is where that -2 comes into play. So when t or x is equal to 0, v is equal to -2. So -2 is equal to 0 over 2 minus cosine of 0 plus c. So that's just going to be -2 is equal to -1 plus c. So c is equal to -1. So our final equation is going to be x squared over 2 minus cosine of x minus 1. And so this is the point where you should grab your calculator again and clear this equation. And then start up on the next one. So you have x to the second divided by 2 times cosine of x minus 1. Okay, so we have this equation and we go graph. Okay, so here we have kind of a parabolic shape, and we're going to want to find those x values, or I'm sorry, those 0 values. Left bound down here, right bound up here, and enter one more time. And we get that the x value is equal to 1.478. And so that is the point where it crosses the x-axis. And the real trick for this problem is realizing you have to take the integral of acceleration in order to find the velocity function. And also you have to remember to add that c at the end. And also make sure to keep your calculator in radians, because that will throw off your answer completely if it's in degrees. And alrighty guys, that's 85 through 87. Hope it was good for you.
For the year 2014, question number 5. The question says a twice differentiable function f and g are defined for all real numbers x. So values of f, f prime, g, and g prime for the various values of x are given in the table above. So they split up the interval from -2 to 3. Looking at this graph, we can tell that -2, -1, 1, and 3 are all critical numbers, -2 and 3 being critical numbers because they're the endpoints, and -1 and 1 being critical numbers because that's the point where f prime is equal to 0. The first question says, find the x-coordinate of each relative minimum of f on the interval -2 to 3, and it says justify the answers. So you're given any graph, a graph like this. There are many relative minimums in this graph because you could split up each section into different intervals and then see what the lowest point is. But say we're taking this interval, the relative minimum is the point on this interval where the tangent line that goes to that point has a slope of 0. Basically what we're finding is the point where the slope of the graph changes from a negative value, so a value going down, to a positive value, creating a concave up sort of shape. Back to this chart, we need to look at the f prime section because f prime is basically the slope, f prime is a derivative. So as we study the values from all these different intervals, we can see that from -2 to 1, the value of f prime stays as a negative value. And 1 is actually the turning point because from 1 to 3, not including 1, the interval is a positive number. So that says that 1 is a turning point, and there is only one turning point in this graph of f prime of x because there is no other change in the slope or the value, and that means that 1 is the only relative minimum in this graph. Let's take a look at the second problem, letter B. Explain why there must be a value c for -1 is less than c, which is less than 1, such that f double prime of c equals 0. Basically, they're asking us to prove the mean value theorem and prove why it is applicable to this scenario. The mean value theorem has 3 parts. It says let f be continuous on the closed interval a comma b and differentiable on the interval, it's an open interval, a comma b. And if these two situations are true, then there exists a number c in the open interval a comma b such that f prime of c equals f of b minus f of a divided by b minus a. And so we know that there is a defined value for every single point in the closed interval a comma b, a being -1 and b being 1. And we also know that it is differentiable in the interval -1 to 1 because it is a continuous function in the interval -1 to 1. So basically all we need to do is plug -1 and 1 into the formula f of b minus f of a over b minus a and solve and see if it gets us 0. We know that f prime of 1 equals 0 and f prime of -1 equals 0, so 0 minus 0 equals 0, and 0 divided by anything is 0. And therefore we can prove that by the mean value theorem there is at least one value c, and that value is in the interval -1 to 1, so that f double prime of c equals 0. So letter C says the function h is defined by h of x equals ln of f of x. Find h prime of 3. Show the computations that led to your answer. Basically, all we need to do is find the derivative of h of x, which is basically the derivative of ln of f of x, and then we have to plug in 3 into this value, or this function. So basically, we're using the chain rule, and we know that the derivative of ln of x equals 1 over x, and in this case it is ln of f of x, so basically it's 1 over f of x, and times the derivative of f of x, which is f prime of x. And so going back to the table, all we need to do is plug in the value for 3, and it's given in the table. It says that the value for 3 of f of x is 7, and f prime of x is 1/2. And we plug that in to get the answer 1 over 14. And last but not least, letter D says evaluate the integral of from -2 to 3 of f prime of g of x times g prime of x dx. Once again, all we're finding is the antiderivative of this equation given. And if you actually take a close look at this, you can tell that this is basically where we've done the chain rule of the function f of g of x, because we're doing f prime of g of x times g prime of x. So all we need to do is plug in the values of -2 and 3 into f of g of x, and we get f of g of 3 minus f of g of -2, and that gets us f of 1, because g of 3, as given in the table above, is 1, and g of -2, as given in the table in the question, is -1. And f of 1 and f of -1 are also given, and f of 1 is 2 and f of -1 is 8, so we do 2 minus 8, and that gives us -6.